Hello everyone. This question has been taken from Olympiad Pathfinder. Multiple choice question number 23 from chapter 2 based on Newton's law of motion. The question goes like a block of mass 5 kg rests on a horizontal floor. When a constant horizontal force is applied on the block for a time interval of 5 seconds, the block slides on the floor a distance 5 meters under the action of this force, and after the removal of the force it further slides a distance 1 meter before coming to a stop. Acceleration due to gravity is to be taken as 10 meter per second square. So options are: magnitude of the applied force is 112 Newton, B, the maximum speed acquired by the block is 2 meter per second, coefficient of friction between the block and the floor is 0.2, the block continues to move for 1 second after the removal of the force. So let us discuss the solution of this question. I have made a diagram for the block. So I have assumed that it has started from A, and till B the force F was applied. At B the force F was removed. This F force removed. Okay, and after that it goes, the block moves further and stops at C. The distance traveled or traversed by the block from B to C is equal to 1 meter given in the question. Okay. The surface is not frictionless. So friction force will act always against the motion of the block. Okay. So block is moving in this direction, X direction. So friction force will small f will be acting in the opposite direction. Since reaction force and weight of the mass is counterbalancing each other, there is no motion in the y direction. Therefore, reaction force is equal to mg all the time. So friction force throughout the motion will remain the same, because your normal reaction is throughout it is same. Okay. So in the question it is given mass, we have assumed that represented it with m is equal to 5 kg. A B is given 5 meter. BC is given 1 meter. Time for the block to reach from A to B is given, that is 5 seconds. Okay. The block started from A point, means V subscript A was 0. The block stopped finally at C, so V subscript C is equal to 0. Okay. And let us assume that the velocity of the block when it was at B is V subscript B. Okay, so I have written down all the things over here. Like, let us say due to the applied force F, the block moves with an acceleration A. This is the A acceleration we have assumed along the x-axis. The friction force is F, small f, on it due to the rough surface. Coefficient of friction we have taken it as K, small k. The force F was applied till the point B, from A to B. Yeah, okay. From point B, the block moves due to the acquired velocity VB. Okay, because it was having a net acceleration in this direction till the time this capital F force was applied. So it has acquired a velocity VB at the point B, and from there F was lifted up, means F stops working in from B point. Okay. The force F was applied till the point B. From point B, the block moves due to acquired velocity V subscript B caused by the force F acting on it till B. From point B, only the friction force F will act on the block, causing a retardation A subscript B. Finally, the block comes to rest at C. So this is the explanation what I've written over here. So we will write equation of motion for the passes A to B. Okay. So VB, velocity at B, will be equal to velocity at A plus acceleration into T subscript A capital B. Okay. Since VA is equal to 0, so we have directly written 0. Okay. TAB in the question is given 5 seconds, so we have put the value. So VB is 5A. This is equation number 1. Okay. Now the second motion of equations, we will write final velocity square. Square of the final velocity means square of the velocity at B is equal to square of the velocity at A plus 2 into A into the distance travel. So that is AB, right? And we have put the value now 2 into A into 5. So VB square is equal to 10A. This we have taken it as equation number 2. So from 1 and 2, you put the value of VB in number 2 equation. Okay. So you will get 25A is equal to 10 and acceleration means A is equal to 2 by 5 meter per second square. Okay. Similarly, from equation 1, now you know the acceleration value, so you can put it over here A. So you will get VB is equal to 2 meter per second. Okay. So one of the option is given that it will acquire the maximum velocity that will be 2 meter per second, because after this there is no force acting and no net acceleration in this direction. So at B this velocity will be maximum, because after this friction forces are acting in the opposite direction and it will start slowing down the block. So B is the point where it will have the maximum speed, and which is 2 meter per second. So this is there in the option, so you can select that option. Now there's no motion in the y direction. Thus reaction force of the ground to the block is equal to weight of the block, right? R is equal to mg. Therefore friction force F will be K into R. This is equation 4. Now we will make the free body diagram of block when it was at A. This is mg, the weight, reaction of the ground, R, F was the applied force, small f is the friction force, A was the acceleration. So from Newton's law of motion, we can write in the x direction F acting rightward, small f acting leftward, so F minus F is equal to mass into acceleration. Okay, so this is equation number 5. Now we will writing equation of motion for B to C. So again the final velocity means velocity at C, it is 0 because block came to rest over there. So VB square minus 2 into AB, A subscript B into BC, right? So this is equation of motion, so you can put the value. Okay. So AB you will be getting 2 meter per second square, means acceleration of the block when the F force stopped working. So this is 2 meter per second and acting in the negative of the x direction because it is a retardation. Okay. Now VB, velocity, from, and again from the equation of motion, you know that VB minus AB TBC is equal to VC. So VC is equal to 0. So VB is equal to AB into TBC. So this calculation you can do by yourself. Okay. This equation of motion you can write by yourself. Therefore, TBC from here we will get, because VB we have, AB we have. So TBC is 1 second. So this is also one of the option. Okay. Free body diagram of block when it was at B. Why? Because we have to calculate K, right? K is the coefficient of friction. So here only the friction force is acting, and that is in this direction, and that is why it is causing a retardation. AB also acting along the friction force, right? So I'm into AB. So from here friction force we got 10 Newton, because M you know, AB you know, so it's just 10 Newton. Up. Now the friction force is equal to K into reaction force, and reaction force is equal to mg. So F is equal to K into mg. So K is, finally if you put the value of F and mg, then you will get 0.2. This is also one of the options. Okay. So from equation 5, now this equation we will use for getting this capital F. Okay. F minus F is equal to ma, what we had written here. So F you bring this side, so it has become F plus m into A. F you know, you have already got 10 Newton, plus mass you know 5 kg, acceleration you have 2 by 5. Okay, that we have calculated earlier. So total is coming, capital F is coming as 12 Newton. So we can collect all the result over here. Velocity at B, which will be maximum, is equal to 2 meter per second. Applied force F, capital F, is equal to 12 Newton. And coefficient of friction K is equal to 0.2. Time taken from B to C for the block to reach is 1 second. Okay. So all options A, B, C, and D are matching with it. So all options are correct. So hopefully you understood all the steps. And in case any doubt, please write in the comment box. I will clarify your doubt. Thank you.